All right, guys, this is going to be the Unit 2 review key. All right, just like last time, you don't have to watch this whole thing. If you want to skip around to the questions you struggled with, you can. I'm just going to go through every problem and how to do it. So number one, we've got three figures here. What is happening each time, right? Well, this is being divided into two pieces. This is being divided into four pieces. This is being divided into six pieces. So the number of pieces it's being divided into is double, or is being added by 2 each time. So we would need a figure here that has 8 pieces. And then we would need to shade in one of those pieces, right, in the top left. Number 2. What is the next number in the pattern? Well, if we look at the pattern, right, it's going up by 2 each time. So if we continue that, our next number would be 17. What is the 13th number? Well, this is the first, second, third, fourth, fifth. This is the 6th. So we need to add, 7 more? That's 7, 8, 9. This is hard to do. It's hard to say numbers and write different ones. 9, 10, 11, 12, 13. So I believe the 13th number would be 31. Determine whether the conjecture is true or false. If false, give a counterexample. All right. A and B are right angles. Conjecture A is congruent to B. Well, a right angle means that they're 90 degrees. So if they're both 90 degrees, then they are congruent. That's true. Given WX equals XY, WX and Y are collinear. I'm going to say that one is false, all right? Just because they're the same doesn't mean they're collinear. What if it was something like this? W, X, Y, right? These are congruent, but not collinear. They're not all in the same line. Every pair of congruent angles are vertical. False, all right? Vertical angles are congruent, but not all congruent angles are vertical. I'll show you right here. Boom. Those angles are congruent, not vertical. If the product of two numbers is positive, then the two numbers must be positive. All right? Is that true? I'm going to go with false. Product means multiplication, right? So it says if the product of two numbers is positive, the two numbers must be positive. What about 2 times 1? All right? 2 times 1 is 2. 1 is odd, so that would be false. That's two numbers that are positive, but... or two numbers where the product is positive, but they are not. If two angles are adjacent, they are a linear pair. False, false, false. Adjacent are any angles that are next to each other, all right? These two angles right here are adjacent, all right? They're next to each other. They share a side. They share a vertex, not a linear pair. If a number greater than 2 is prime, then it is odd. That is true, all right? Because any other even number greater than 2 is divisible by 2 and thus not prime. Write each statement in if-then form, all right? All students like vacations. So if-then form, that's a conditional statement. So if you are a student, then you like vacations. All right, the next time, every time it rains, my knee hurts. So if it is raining, and these aren't the only answers for these ones, but this is just one way to write it. If it is raining, then my knee hurts. All right, as long as you are using if and then and breaking your statement up into 2 parts, and it's grammatically correct, you're fine. Write the converse of the conditional statement. If I win first place, then I will get a medal. Remember, converse, all right, is flipping these two spots, all right? So the converse would say, if I get a medal, then I won first place. And that would be false, right? You could have won second place. Or third place. All right. Write the are the following statements true by conditionals? Explain. Remember, a biconditional is if it says if and only if, all right? Point A is between C and T if and only if A is the midpoint of CT. Well, that is false, all right? That is definitely false. A could be between C and T and not be the midpoint, right? We draw that picture all the time. All right, A is between C and T, but it's not the midpoint, so that's false. Two lines are perpendicular if and only if they intersect to form 90-degree angles. That would be true, all right? That's the definition of 90-degree angles. Or sorry, that's the definition of perpendicular. Even though we haven't talked about that in this class, you guys should know what perpendicular lines are. All right. State the conclusion that can be reached using the law of detachment or the law of syllogism. If I go for a bike ride, then my legs will get tired. If it's a nice day, then I will go for a bike ride. All right, so if you look at how this is set up, we're going, it's a nice day, all right? That's leading to bike ride, all right? If it's a nice day, then I will go for a bike ride. If I go for a bike ride, then my legs will get tired. So it's going nice day to bike ride to legs being tired. So when we start, all right, we want to start with, if it's a nice day, if it's a nice day, then my legs will get tired. For some reason, I cannot write my eyes right now. Then my legs will get tired. So we're skipping over the bike ride part, right? The bike ride is the chain that's linking together nice day and legs being tired. Angles that are complementary have measures with a sum of 90 degrees. A and B are complementary. So what can we determine? Angle A and angle B have measures with a sum of 90 degrees, right? And that would be the law of detachment. Okay? Next, give an example that uses each algebraic property. I'm going to go through these real quick, all right? Reflexive property. Something is equal to itself, all right? Symmetric property, if x equals y, then y equals x, all right? Transitive property, if x equals y and y equals z, then x equals z. Distributive property, if x times y plus z, that equals xy plus xz. Substitution, if x equals y, I don't even know what an example for this would be. If x equals y and y plus 2 equals 5, then x plus 2 equals 5, right? We're substituting them in. Multiplication property of equality. If x equals y, then x times z equals y times z. All right, you can multiply on both sides. Division property, if x equals y, then x over z equals y over z. Subtraction property, if x equals y, then x minus z equals y minus z. Then addition property, if x equals y, then x plus z equals y plus z. So we're going to be using these properties to do some proofs, all right? Complete the algebraic proof, all right? So remember, when we're writing a proof, we always start with the given, all right? So that's what we're given. Now, what are we going to do? All right, well, I want to get my x's on both sides, so I'm going to add my 2x over. All right, so my second statement, that's going to cancel out, right? So we've got x, 8 plus x equals 7. And that would be the addition property because we added on both sides. All right, next we are going to subtract 8 from both sides, and that's going to give us x equals -1, and that's what we were trying to prove. So we're actually done after that, so subtraction property. So this was a pretty nice equation to solve. It was only 2 steps. Now, could you have done it a different way? Yes. Just make sure that you write out all the correct steps if you did it a different way. All right, complete the following proofs. All right, let's do this. So proof number 1, C is the midpoint of AB is what we are given. C is the midpoint of AB, okay? And DC is congruent to CB. All right, so those are our 2 givens. Our reason for that is given. So I'm going to mark down on our paper what we just got told. C is the midpoint of AB. That means this is congruent to this. So that's automatically my next step, right? Whenever I see midpoint. So I know CA is congruent to CB. Actually, let's call this AC because that's how they called it. All right. So that would be definition of midpoint. Okay. Next, we're trying to show AC equals DC. Well, this is just going to be the transitive property, right? AC equals DC, or we could say AC is congruent to DC, because they're both congruent to CB, right? DC is congruent to CB, AC is congruent to CB, so therefore AC is congruent to DC. That'd be the transitive property. And you know what, guys? We don't even need this 4th step. All right, I'm not going to make you do anything. AC being congruent to DC and AC equals DC, that's the same thing, all right? So that's our proof. We don't even need the last step. I'm not going to worry about semantics. All right, 18. All right, this one looks like a long one. Let's see how it goes. Given M is the midpoint of AB. You know what, to save time, I'm just going to put this down here. I know you guys have to write on your test, but I'm trying to make, what? Okay. M is the midpoint of AB, B is the midpoint of MD. That's our given. So again, we need to mark this, right? M is the midpoint of AB. So I know AM equals MB. So I'm immediately putting that down. AM equals MB. That's definition of midpoint. What do I know next? I know B is the midpoint of MD. So that means MB equals BD, okay? MB equals BD. Nice. That's also going to be definition of midpoint. Now, because of that, right, don't I have three congruent lines here? So if AM equals MB and BD equals MB, I also know AM equals BD. Now, I don't even know if I'm going to need that, but let's put that on. AM equals BD, right, because they're both equal to MB, all right, if you look right there. So that would be the transitive property, our favorite property. Now, what are we trying to do here? We're trying to say that MD equals AB, all right? Well, I know that's the same because they're made up of congruent parts, all right? So let's use the segment addition postulate, all right? For both MD and AB. So AB, that's AM plus MB. Equals MB. And then let's do the segment addition postulate for MD. That'd be MB plus BD. Equals BD. Or sorry, equals MD. What? Okay, guys, I can't get my B's and D's straight. That's MB. MB plus BD equals MD. All right, now I'm trying to show AB and MD are equal, right? Well, I already have them both being equal to MB, all right? This is the part that's different, so if I can get that part to be the same, then I can use the transitive property. And sure enough, here we just proved, all right, that AM equals BD. So I can use substitution here to substitute this BD out for AM. And that would be substitution. Oh my gosh, I've not been writing. Both of those were segment addition postulate that we just used. SAP, segment addition postulate. All right. And now we're about done, right? Because now we have MD equals MB plus AM and AB equals AM plus MB. So those two are the same things, right? Order doesn't matter with addition. So now we can say MD equals AB, and that would be by the transitive property. And we're done. So that was kind of a long proof, but it's not using anything you guys don't know. I think that you guys could have got that proof. Next one, given GE equals 48 degrees. GEA, angle GEA is 48 degrees. And also, angle GEM equals 70 degrees. So this one they're actually giving us numbers, all right? So GEA, that's 48 degrees. And then GEM, so the whole thing, that's 70 degrees. So they want us to prove that AEM is 22. So here we actually do know numbers, all right? This is given. So we can use our angle addition postulate here to start adding these together. So the measure of angle GEA plus the measure of angle AEM equals the measure of angle GEM. All right, that's our part plus part equals whole. Now we know two of the parts, right, that we were just given, so we can plug those in. So we know GEA, that's 48 degrees. We don't know AEM. That's what we're trying to find. And we know this is 70 degrees. All right, so this was the angle addition postulate. We know this was substitution, all right, because we knew their values, so we could substitute that in. And then now we just need to solve. So if we subtract 48 on both sides, we get the measure of AEM equals 22 degrees. And since we subtracted on both sides, that would be the subtraction property. All right, and we are done with our proofs. So that's how you do those questions, right? Hopefully that helped. If you have any more questions, all right, let me know. You can always message me or, ask me if you see me in class before the test. Good luck studying, all right, and have a great day.